Okay, hello everyone. What we'll take a look at today is section 21D, which are the simple rules of differentiation. Now in previous sections, what we've done is we've taken a look at how to calculate the instantaneous rate of change for a function using our basic principle, our fundamental first principles. And that took quite a bit of time because there's so much algebra involved with finding the derivative function. Now what we're going to do next is we're going to look at simple rules for differentiation. In other words, we're going to go straight from the function to the derivative without having to use those first principles and that large algebra technique to use and using the limit of the average rate of change. So what we're going to do first though is before we actually take a look at these simple rules, let's give everybody a big overview of what you can actually do with functions, because this is going to be the absolute key. You have to be able to, one, recognize the function, and you have to recognize the parts of the function and what kind of operations are being acted upon the functions. If you can do those two things, then differentiation is very simple. Okay. So what can you do with functions? These are the things that you can do, is you can just take a function and you can multiply it by a number called c, any number, 5, 10, pi, square root of 2. Okay? The other thing that you can do with two or more functions is you can add or subtract them together. The other thing that you can do with functions is you can multiply them together, divide them, or you can compose them. This is it. Those are the only things that you can do with functions that we know of in mathematics. So, multiply it by a number, add or subtract two or more, multiply or divide two or more, or compose functions. Okay. So, if you can then go ahead and think about all the simple rules that we'll have to be able to cover all of these cases, and there are about 15, you'll be able to differentiate any function that's given to you without having to go through the first principles. Okay, so let's take a look at some simple rules then, so that we can go ahead and take care of things here. And what we're going to do is we're going to take a look at these two first, number 1 and number 2. Okay, and what we're going to do in order to actually do that is we have 4 rules that you need to remember. Okay, the first rule says, what if you have a constant function? So in other words, what if y is equal to f of x is going to be equal to c? So let's give a concrete example of that. Like say for example y, which is equal to f of x, is equal to 10. What is the derivative of that? If you have a constant function, now remember the reason why this is a constant function is there's no variable here. So it is constant. What is the derivative of this function? And in order to take the derivative of a constant function, the derivative function is always 0. So, therefore, if this is what the function is, then y prime, which is the same thing as f prime of x, or the derivative function, is always going to be equal to 0. Okay, so let's go ahead and try another one. What if I take negative 10? Okay, same answer. What if I take negative pi? Well, same answer, because that's a constant. What if I do negative 5 times 10 to the negative 846. Same answer. This function right here is a constant function. The derivative of a constant function is always 0. Okay. Let's take a look at another situation here. That was the constant rule. Now let's say for example that you have this next part situation here where it is not a constant. So in other words, you do have a variable, and what happens in that situation? So let's say, for example, that you have y is equal to f of x, which is equal to, let's just say, x to the 4th. Okay? Now, if you have y is equal to f of x, which is equal to x to the 4th, in order to go ahead and take the derivative of this, which is no longer a constant, but it's going to be a variable raised to an exponent, and in this case it's 4. The way that you do that is y prime then, which is going to be equal to f prime is going to be, well, you take that value, which in this case is 4, x, right? And the exponent becomes 1 less. So that's going to be to the third power. Okay, let's try another one. What happens if you have f of x is equal to x to the 10th? Then what that means then is that f prime of x is going to be equal to 10x to the 9th. What other kind of numbers can you come up with? Well, can you do something like this? X to the negative 10th power. Sure, it's the same procedure. F prime of x is equal to negative 10x to the negative 11th power. What about fractions? F of x is equal to x to the, let's just say, what do we want to do? Let's say 1/2 power. Okay, well, that's just going to be f prime of x is equal to 1/2 x to the negative 1/2 power. And there you go. So notice how simple this is. If you remember what the rule is for the particular type of function that you're given. The only two ones that we have right now is a constant function and a function that's very simply stated as x raised to a power.